Hello, my name is Rafał Szypułka and I am the author of the Grafana data source plugin for IBM APM. In this video I would like to give a brief overview of the IBM APM plugin for Grafana, walk you through example dashboards and show how to create a custom dashboard. IBM APM plugin adds another data source type to Grafana, which is IBM APM. It supports both IBM T-Volume Monitoring version 6 and IBM Performance Management version 8. Data source connects directly to IBM APM metric REST API and collect metrics data based on the queries defined within dashboard panels and time range defined for a particular dashboard. Plugin includes Visual Query Editor, so you don't need to know the API. You just need to select things like agent type, attribute group, attribute and agent instance, plus optional filters, and in most cases you are ready to go. Plugin supports also Grafana template variables, so you can define, for example, static or dynamic list of agent instances and add it as a drop-down menu to dashboard to easily switch views between agent instances. I will show some examples on this video. Plugin is free and open source, anyone can use it and contribute. Plugin and documentation are available on my GitHub. End-to-end deployment process is also documented there, and it is also documented on another video I published. Here you can see the basic data flow for Grafana installed on-prem close to APM monitoring servers. It is recommended to access Grafana server through the Nginx reverse proxy. The reason is explained in the plugin documentation. Another option is to have Grafana and Nginx deployed in the cloud, for example in IBM Bluemix. Grafana is deployed in IBM container and connect to on-prem monitoring server through the Bluemix secure gateway. This particular architecture is used for the example dashboard I will show now. Here you can see the live demo I prepared to showcase the features of the Grafana and IBM APM plugin. On the first dashboard, data is collected from APM version 8 and show various Linux operating system metrics for the last 3 hours. This time range can be easily changed here. For example, we can change it to the last 6 hours, and all the panels are automatically updated. We can also select region on the chart to zoom to specific time range, and automatically, as you can see, all other panels are updated. On this dashboard we can see various types of panels. This one is single stat panels that shows single value. In this particular example is percentage use of virtual storage, and it shows the current value. On this chart you see the line chart that shows CPU busy percentage per core, and these lines are stacked here. In the legend you see various aggregated metrics like minimum, maximum, average value and current value. This is a table type of panel with the file system utilization and the same value shown on the bar chart. This drop-down menu allows to switch between agent instances. This menu is created dynamically based on the Grafana template variable and will be automatically populated with the list of the agent instances of the particular agent type. And after we switch to another agent instance, all the panels are updated with the metrics data for this particular agent instance. Another example is a dashboard based on the data collected from the ITM6. It looks exactly the same as the previous one, and it is just to show that We have exactly the same set of features for APM 8 and ITM 6. This dashboard is collected based on the data from the agent ITM 6 agent. Another example is a mashup of data collected from ITM 6 and APM 8. This is just to show that Grafana is very flexible in mixing data from various data sources. So on the same chart we can show the data collected from different agent instances and even from different monitoring servers. First two lines are collected from APM 8 from two different agents, and the blue line is created based on the data from the ITM 6. Everything shown on the same chart. Another example shows the repeated row Grafana feature. In this dashboard you can see panels defined in the single row, and based on the template variable we have drop-down menu, and in this drop-down menu we can select the agent instances we would like to compare. If we select two instances, the row with panels will be automatically repeated for another agent instance. We can also contextually drill down to more detailed dashboard in context of the current agent instance. For example, the links are defined here, and we can also click on the single stat panel to move to more detailed dashboard. Another example shows the sample IBM stack monitoring. This dashboard is created based on the data from many various types of APM agents. And the first two panels shows metrics collected by the Linux operating system agent, and this panel shows the DB2 log space used collected by the DB2 agents. And this panel shows the MQ queue manager status collected by the MQ agents. Another panel shows the status of the IIB broker and connection status from the broker to its queue manager. This row shows the data collected by the HTTP server agent. Here we have the HTTP server status. And on this heat map panel we see the number of requests visualized as a heat map. And the last row shows the example WebSphere application server metrics like number of active threads and also the average response time for the current active requests going through the WebSphere application server. Example contextual drill down is defined here for the IIB broker. So when we click on the single stat panel, we will be moved to the more detailed dashboard with metrics of this broker. Another example dashboard with the transaction collected by the response time agent. On the single chart we see various types of values. The bars shows the number of requests, the green part shows the successful requests per transaction, and the red part is the number of failed requests, and the lines on this chart shows the response time. So as you can see we have two y-axes on this chart. This one shows the number of requests and the right one shows the response time in milliseconds. And this is also example of the repeated row dashboard. We can select which applications, and in this case web servers, should be visible on the dashboard. The last two examples were created based on the data collected by the custom APM agent built with the agent builder. The agent collects the simulated transaction volumes for various transaction types. This is also a repeated row type of dashboard. We can select which transaction type we want to show on the dashboard. The same data in another example is visualized using a flowchart panel. This is a statically defined flowchart, but particular flowchart items can be dynamically mapped to specific numeric values and dynamically colored based on the thresholds defined within panel definition. Now I will show how to create a custom panel from scratch. In my demo environment, let me switch to my sandbox organization, and this is how we create new dashboard. From the menu, create new, and I will start with graph panel. So drag and drop the panel type to the row and click on the panel title, choose edit. We need to specify the data source, previously defined the connection to the APM server. And now we just need to select proper agent type, attribute group, and attribute from the drop-down lists. So click on the select agent type, and here on this list, this list is dynamic, created using REST API request to the APM server, and it shows the full list of agent types configured on the server. I will use the Linux OS agent. So this list is dynamically searchable. So let me choose the Linux OS agent type. Then filtered list of attribute groups for Linux OS agent type. I will use the CPU attribute group, KLZ CPU, and we are interested in the CPU busy present. Busy percent, and if there is primary key defined in this attribute group by CPU ID. Now we just need to select the agent instance. We have currently two Linux OS agents connected to the APM 8 server. And now we should see the results. If we want to modify how the series are visualized, we have many options here. First, let's filter it a bit. We are, let's say, interested only in aggregated CPU utilization. So let's filter by CPU ID equals -1. This is how aggregated value can be queried. We can change the panel title here. We can add some description to the axis. And change units to percent. We can also modify the legend just to show it, for example, on the right side, and put some additional information like minimum, average, maximum, and current value for the period specified here in the time range. Show it as a table. And if we change time range, it should be automatically populated. If we want to modify something, we just need to click on the panel title, go to edit, and we can change anything we want. Let's say remove this filtering. And for example, we can show these lines as stacked lines. and change time range to 3 hours, let's say. Now I will define a drop-down menu with the dynamic list of the agent instances, so we can easily switch between agent instances. To do this, I will define the template variable. I will need the agent type affinity name. This is the value I would need to copy. And from this menu, I will define new template. New, let's name it agent name. And the data source, refresh on dashboard load, and in the query we need to put this obscure string, and here you can see what is the results of the query. We have this list of 2 agent instances of the Linux OS agent name. Add, and we see this list here. At the moment, if we change, there is no change. We need to specify variable name inside the query attached to the panel, and this is the place where we need to specify our variable. Instead of specific agent instance name, we need to put the variable here. Okay. And now when we switch between agents, we should see the change. We can modify the label for the chart. And it will change together with chart. Okay, so this is how we define the custom panels. It concludes the video agenda. Thank you for watching.